Hi all, good morning. In the last session, we have discussed the fundamentals in multi-threading. We have seen how to write a multi-threaded program using the thread class. Or to define a multi-threading activity using the thread class, we need to define a subclass that extends the thread class. Then in the next step, we need to override the run method, public void run method. That method, right, should be redefined inside the thread class. So inside the run method, we need to define the multi-threaded activity. We have created three different classes, say class A, class B, and class C. We have created three child threads, say small a, small b, small c. We try to call the corresponding run method of the three different classes using the child thread objects A, B, C, A dot start, B dot start, C dot start. It seems that in different runs, the outcome of the program is going to be varying. First run outcome is completely different from the second run. We can see at different runs, the outcomes are completely varying. Now to illustrate the sleeping time, have a look into the statement. Thread dot sleep of 1000. In case here, if you are setting thread dot sleep of 1000, what happens after the child threads A, B, C are created? Then the main thread is waiting for 1000 milliseconds. That state, control may go to execute the corresponding child threads. See how it has been enforced. What is the first line to be executed? End of main thread. Even here, we can see some the sleeping time is a very minimal quantity. You can observe that 1 second is going to be elapsed here. After that 1 second, the child thread activities are called A dot start, B dot start, C dot start. But before the control enters into the corresponding run method, main thread finished its complete execution. Runtime 1 second is actually right realizing here. For example, see this is that 1 second elapsing. In case if you set the sleeping timers, say I'm giving 9000. Now see when the main thread is sleeping for 9000 milliseconds, that is 9 seconds, the child thread may start its execution. But here, the objects are created in the sequential order A, B, C. Then, before the call of start method, you set the main thread is waiting for 9000 milliseconds. Now the question is that state, is it possible to call or invoke A dot start, B dot start, or C dot start? That is the question. And to predict the scenario, because of that 9000 milliseconds, main thread is waiting for say 9000 milliseconds. It will not execute the call of child thread activities. As I said earlier, the statements are executed in the sequential order. Since before calling A dot start, B dot start, C dot start is set the sleeping time of 9000 milliseconds. So 9000 milliseconds can be realized during the runtime. That much amount of time main thread is waiting. After elapsing that, say 9 seconds, then only main thread continues to call its execution or to call child thread's execution. So here, right, if you set right, say 1000, after the call of A dot start and B dot start, here if we try to set say 5000 milliseconds. Now what happens? The threads are executed in the random order. A main thread starts its execution. Here main thread is initially waiting for 1 second. After that it goes to execute its own statements. Say or it may initiate child thread A or child thread B. Then what happens means here thread dot sleep of 5000. When the control is transferred from child thread to main thread is waiting for 5000 milliseconds. After that, only it can go for executing a C dot start. So in that time, it is expected to have the complete execution of child threads A and B before the start of the child thread activity C. Let us check that. Initially, one time, right? Sorry, 1 millisecond. Sorry, 1 second. Elapsing is no. After that, right here, the child thread activities A and B are started. Then main thread is waiting for 5000 milliseconds. That stage, right, you can see the message. End of child thread in class B. End of child thread in class C. Then even main thread finishes its execution. Then a C dot start, right? This doesn't mean that this line is executed first. Then C dot start has been called second. Actually, C dot start has been called. Then before the control goes to print something inside the run method, the fraction of milliseconds control comes back to the main method to finish its execution. End of main thread. Anyhow, we can infer the child thread activities of C. 7,000, 8,000, 9,000, 10,000, right, will be printed only after the complete executions of A and B. So here 7,000, 8,000, 9,000, and 10,000. Then end of child thread in class. Understand or not? Having any queries in this example? So here at the end of the main method, before the write, you try to set higher time. For example, thread dot sleep at 2000 here. So that what will happen means, before the completion of the main thread, we are going to expect that the child threads should complete their executions. So that
Sir,
main thread is expected to have the thread
sir,
to execute, finish its execution at the end. Yeah.
sir,
Yes, tell me.
sir. Once go back to that program, sir. Once. Sir, in that thread dot sleep of 1000, is it for main method, sir?
Yeah, it's from main method. Even you can provide it inside this method, run method. Here also you can provide the same run method. But you need to define the method as well. That throws interrupted exception. Because sleep throws interrupted exception. The next example is where we try to use the sleep method inside the user defined classes here so that it can also be controlled through the try catch mechanism. Shall I move on to the next example?
Sir, can we provide thread dot sleep inside the class, sir? Class A, B, C, and all?
Yeah, that's what I say. In the coming examples, we try to use in the debate. Before going to that, right here in the previous example, we have written the code class A extends thread. Public void run has been implemented. Then a compute method is called. Then some other classes are defined. Here we would like to implement the multi-threading concept for a single class. So classes B and C are cut, right? Only for one class, we have created three objects: A1, A2, and A3. A1, A2, A3. Three objects are created. We are trying to call the methods, run method corresponding to these three objects: A1, A2, and A3. So when A1, A2, and A3 are trying to call their own run method, we do like to know that which child object is currently entering in the run method. That we want to know that. So if you do not specify any name, then you cannot infer which child thread has actually inside the run method, or which child thread is currently in the running state, which child thread finished its execution, that we do not know. So for that purpose, right, what we are going to do is here we are providing a string argument constructor, right? The string argument constructor, one argument constructor is defined here. A class is A, the string str. You can easily copy right one string into another string. Very simple in Java, right? The string s1 is equal to hi, how are you? String s2 is equal to s1 means the value of s1 is copied into s2. So you can directly assign one a string instance to another string instance, or one object or string into another object of a string class. So in C and C++, you need to find out the equivalent, right? strcpy function copied from the source into the object, not necessarily here, directly assign. st is equal to str, st is the string instance. Inside the run method, right? So the particular object, right, whenever it enters into the run method, we do want to check who is actually or currently entered into the run method. So for that purpose, the corresponding object, the string argument name, which is received in the variable string instance variable st, is going to be printed here. So that this st is the significant one which identifies who is actually printing the value of I, or who is actually entered into the run method. Then same thing, right? A compute, right? A compute has been called. Only thing is, three objects are created for a single class. So two classes are created. We are trying to call a1.start, a2.start, and a3.start, and finally, right, we set the sleeping time of 5000 milliseconds, which is equal to 5 seconds. Now let us check this code. Java multithreading code.java, Java multithreading. Compare with the main method statements. Here, main thread initially three child objects a1, a2, a3 are created. But in the first line, if you write main is calling, since main method statements are executed in the sequential order, you can find that right main is calling as a first statement. After that, right, the objects a1, a2, a3 are created. Main method is trying to call a dot start, a1 dot start, and a2 dot start. So it seems that a1, a2 started. Here this message is printed. A1, A2 started. Thread dot sleep of 5000, while the main thread is waiting for 5000 milliseconds. Since A1 dot start and A2 dot start has already been started, right? Let us check the result. Here something, the part of right A1 and A2 are completed. Here you can see I in A0 child thread at the end, right? See the corresponding object name A2, A1, A2, A1, A2, A1, A2, A1, right, etc. Then child thread A2, child thread A1. Sum is printed for the two child threads. End of child thread A, end of child thread. End of child thread A, end of child thread A. That means we have given this message. End of child thread A. Twice for objects A1 and A2. Then A3 has been started. You can see the message A3 started. A3 dot start. A3 finished its execution. Again, right, we set 5000 milliseconds. So at the end, right, you can see the message end of main. End of main. Here, main thread finished its execution at the end. Before that, child threads are completing their execution. Even in the second run, you try to observe that. You can realize, right, the 5000 milliseconds. It's waiting. That stage, right, the child thread activities are completed. So finally, you can see the message end of main thread. At a different runs, you can see the different outcomes. Anyhow, since we set the higher sleeping time at the end of the main method, It is expected to have to complete the executions of the child thread before completing the execution of the main thread. The end of child thread here also you can provide a value so that you can understand which object has first finished the run method. Having any queries in this example? One class, three objects. Three objects are trying to call the run method concurrently. So this is another example of a multi-threading. The previous example, multiple classes, we have created a independent object for the multiple classes and we try to call a run method. Here only one class, three different objects. Three different objects are trying to complete the run method. Another example of a multi-threading. We have any questions?
Sir, why does this println statement is executed after before at the beginning itself, sir?
Which println?
A1,
A1
A2
A2 start.
started.
Yeah, that's what I explained. Actually, main thread is the first thread to start its execution. Before that, here let me add one more line. System dot out dot println. Say main is starting. Our main starts. In this case, what will be the first line of output? Main starts in different runs. Second run, main starts. So I try to run it for several times. The first line, right, there is no compromise in this. The statements are executed in the sequential order. That is important. Since this is the first println statement, right? First line, first executable statement. Before any objects of class A, A1, A2, A3 are created, this println statement, right, should be executed first. There is no doubt in that. But after that, the three objects are created A1, A2, A3, right? Even the objects are also going to be created in the sequential order A1, A2, A3. Up to this right, no problem. But here, when you call the child thread, right, A1 dot start, A2 dot start, right, there may be some order, right, A1 dot start, right, it may start this or A2 dot start. So in that stage, what will happen is when A1 dot start has been called, here control comes to this run method. It just imagine that A1 dot start has been called without printing any value of form. Then A2 dot start has been called without printing any value of I, specific value of I. Then control comes to execute this println statement A1, A2 started. So in this output, then after this line, main starts A1, A2 started. This implies that three objects A1, A2, A3 are created. Even these two child thread corresponding run method has been called, but control will not enter into, right, or control will not process something as a part of R state. But before processing anything with respect to the bar statement, it returned back to execute some other process in the main thread. So it seems that we can see the message A1, A2 started. But after that, right, when it tried to wait for 5000 milliseconds in the main method, that stage, still A3 has not started, right? So A1, A2 completion is possible while the main thread is waiting for 5000 milliseconds. After that, you can find the complete execution of A3. A3 started. Again, main thread is waiting for 5000 milliseconds. Even if you run the program several times, right, sometimes A1 dot start, right, may start its execution, printing some values of I, then A2 can start. After that, you can see the message A1, A2 started. This need not be unique output in every stage. Main starts A1, A2 started. You run it for several times. try to remove this sleeping times, right, and run it for several times, this output, right, need not be same as after this message A1 A2 started, right? In some cases, what happens means before A1 A2 started, A1 dot start or A2 dot start can partially complete some execution. I think is here.
Sir, but for this one thread dot sleep, in order to execute thread dot sleep, the previous call statements must be executed first. Then only thread dot sleep method will be executed, sir.
Previous can't get you.
In this example, after the execution, complete execution of A1 dot start and A2 dot start, only thread dot sleep of 5000 will be called, sir, or executed, sir.
No, no, no. We cannot predict that. So 1 minute. The sequential execution A1, A2, A3, right? And of course, A1 dot start, A2 dot start are sequentially executed, and then the message A1, A2 started printed. As I said, right, A1 dot start, A2 dot start may transfer the control to the run method without printing anything in that. That means without entering into the for loop, it may come back to execute the main method. That stage, the main thread, right, may be waiting for 5000 milliseconds. Understand? So when the main thread is waiting for 5000 milliseconds, since no other statement in the main are going to be executed in the sequential order, child thread A1, A2 are already started. Child thread activities A1, A2 are not yet completed. So the processor can execute the activities of the child threads A1 and A2. This does not mean that after the complete execution of A1 and A2, thread dot sleep is going to be executed for 5000 milliseconds. Need not be right true for all situations, right? Okay, sometimes right A1 dot start and A2 dot start may start their execution, then it may complete the complete executions of A1 and A2. After that, when it comes to write the main thread, here it may be waiting for 5000 milliseconds. That stage, you will not find any execution of A1 and A2, since A1 and A2 might have completed their executions. But normally here, when the control comes to the main thread, we can infer like this. When the main thread is waiting for 5000 milliseconds, in case the child thread are not yet completed their execution, control, right, goes to execute the child thread executions. But the output is different from current to clear.
Clear, sir.
See the next example as you asked, right? How to bring the sleeping time inside the part of a method. This is the actual code given in your complete reference book. But I have not shown this example right first because I have given the simplest way of writing the multi-threaded program. So what is the simplest way of writing multi-threaded program? You need to define the user-defined class which extends the thread class. Then define the run method. Create an object of the user-defined class. Then call the corresponding run method, right? Using user-defined object dot start, right? In here, right, I try to explain the code which is given in your complete reference books. Some codes of that. See this code: class new thread extends the thread. New thread is the actual name. Extends the thread class. Here, right, the author had defined, right, the run method like this: public void run, right, for int I is equal to 10, I less than or equal to 100, I is equal to but 10. Then the println message is given, say child thread I. The sleeping time is given inside this for loop. Thread dot sleep of 5000. So after printing the value of I is equal to 10, say for example, child thread 10. The next statement to be executed is this one. There is no doubt in that. So child thread is waiting for 5000 milliseconds. So when the child thread is waiting for 5000 milliseconds, Control may be transferred to execute, right? Some other child threads, if any, or it may go to execute the main thread. The lines are to simply write a place inside the try block, try. Then here the interrupted exception is handled right using the catch block, catch interrupted exception. We have given the message a child thread is interrupted. Then at the end we have given the message child thread is exiting, public void run. Then coming to the main method. In main method, what we have to do, there are two ways, right? I explained right all the possible ways. One, you can create the object of new thread class. How to create an object? New thread object is equal to new thread. Otherwise, you can directly invoke the constructor. I show it in the next example. See here, create a new thread. New thread, this is the user-defined class. That is a subclass of a superclass thread. New thread object is equal to new thread. Then normally, right, what is enough? New thread object is empty. Empty dot start is enough. Understand? Empty dot start is enough. Empty dot start simply invokes the run method defined in this class and new thread. But you can also create the thread class object like this. New thread empty is equal to new thread. Then you can create a thread class object. Thread t is equal to new thread of empty. This subclass object should be passed as a parameter to the thread class constructor. Then one message is given. For example, demo thread by extending the thread class. One message is given. Then system.out.println child thread plus t. What is t? T is the thread class object, which is said to be a child thread. See right what is actually going to be printed, right? In the value of t. Then a t dot start. This is another possible way to invoke a run method based on the thread class object t dot start. The direct possible way to call the run method is simply you can use entry dot start. I have commented out this line. Entry dot start. This is also valid. There is no much significant difference between these two lines. That's what in the procedure when we extend the thread class, the last line that I have given this step. Call the start method using the object of thread class or user defined class. The previous examples we have called simply using the start method using the object of the user defined class. In case if you call it using the object of thread class, this is the procedure. You need to create a thread class object. The constructor of thread class must pass right the object of the subclass which has been extended from the thread class. Then this is an optional parameter. Right? There are several overloaded versions of thread class constructors. If you want, right, you can provide some string message. After that, thread class object dot start simply calls the run method. That means child thread starts its execution. While the child thread starts its execution, the run method has been called after printing the value of I by 10, right? Say I is equal to 10. The child thread is sleeping for 5000 milliseconds. That stage, no other child thread is there in the main method. So control come back to execute the main method. In main method, right, we tried write another for loop. For int I is equal to 10, I less than or equal to 100, I is equal to I plus 10. Then the main thread is right, waiting for 10,000 milliseconds. Here, child thread is waiting for 5000 milliseconds. So that stage, the main thread right can be executing for this piece of code. When it encounters this line, thread dot sleep of 10,000, right? So during the runtime, this sleeping time can be invoked. Then the interrupted exception is defined here. Finally, the main thread execute. Here, for example, 10,000 milliseconds are given. First, let us check the code. Multithreading py.java. Multithreading py. Child thread, right? This is the name of the child thread. Thread demo. Thread by extending the thread class. Py comma main. Py comma main indicating that the child thread has been created inside the main method. Py indicates that it's a normal priority. You can see that main thread 10, then main thread is waiting for some milliseconds, right? 10,000. 10,000 means what happens here? It's waiting only for 5,000. So here 5,000 milliseconds, right? It can process. The next 5,000 milliseconds, the main thread is wait idle. So that stage, right? You can see the alternate flow, maybe, right? Main thread, child thread, main thread, child thread, or child thread, right? Can continue its execution. When it comes to the main thread, it may be waiting. Child thread administers its execution. Main thread, right, we have said the 10,000 milliseconds. That is encoded here. Main thread 70, 80, 90, 100, 10 seconds elapsing time. Then 80, 10 seconds elapsing time. Because child thread already completed its execution. Then main thread 90 at 10 seconds elapsing time. After that, child thread 100, main thread 100, again 10 milliseconds, 10 seconds elapsing time. At the end, right, you can see the message, main thread is executed. Understand or not? Having any queries in this? In case of the sleeper time is given, say for example 1000, here 5000 milliseconds sleeping time, here 1000 times. So that stage data you can see main thread may finish its execution earlier before the complete execution of the child thread. But understand one thing, this is also a style to write a multi-threaded program. Simply write you can create a thread class object. The thread class object, write a constructor process the object of this subclass object, 8T. Then using the thread class object also, you can call the start method. This is one possible way. In the next example, right, I think I show you this left hand side part, this may be missing. Understand? So far we didn't see any example in Java.
Sir,
Yes, tell me.
sir, why is the code placed inside the try block, sir? I did not understand that part.
What one? Try.
Try. Why is this code for loop and all are present inside the try block, sir? Why is the try necessary?
Because yeah, one minute I tell you. Here, right, for each value of I, right, you are calling the sleep method. So if you like, right, try can be placed inside the par, no problem. Try opening curly brace can also be moved into this par. Then thread dot sleep. After that, right, close this closing curly brace and define the catch exception handler. There is no error in that. Out of R also you can write a try catch, no problem.
Sir, that means
Closing curly brace.
in case of error to avoid the error, we are using the try and catch in this program, sir. That only, sir.
Yes, yes. If there is any interrupt in operating systems, you may learn, right, some hardware interrupt, software interrupt. That is internal, external interrupts, right? So if some interrupts are taken place, right, then the sleep method rises, which exception means interrupted exception. That stage, your program is to be abnormally terminated. To avoid that, right, we need to write the object-oriented exception handling framework. So as of now, right, there is no internal, external interrupt. So program is working fine.
Sir,
Try catch can also be moved into the for.
sir, for every time, sir, that for loop is executed 10 times. So for every execution, thread dot sleep is called. So it gives an exception, no, sir. Interrupted exception.
It may raise an exception. Yeah, during the execution of thread dot sleep, if there is any interrupt, that line alone results in the interrupted exception. That stage, the raised error will be caught in the corresponding exception handler defined in the catch block.
Sir, main thread interrupt, that println statement is, we haven't seen that statement executed in the output.
Main thread, this line,
Sir,
main thread is
catch
interrupted.
is inside the catch. Yeah, sir. Println statement.
Yeah, this will be executed only when the runtime error is reported inside the try block. So in our case, right, no runtime error is reported. So you cannot see the execution of catch. No runtime error is reported inside the try block, right? So this is also a rule. If runtime error is reported, then it will be tested against the exception handler. There is a match, exception handler is executed, then sequential statements are executed in the order. If there is a mismatch, Java's default exception handler terminates the program execution. Another rule, there is no runtime error reported inside the try block, no execution of the exception handler. As usual, the program execution continues.
Sir, in this program, will the execution of the class method and main method, will there be a pass of 5 and 10 seconds scattered throughout the execution, sir? Or it will be in ordered
Yes.
manner?
Yeah, it will be in the order. I think I can find it because child thread is waiting for 5000 milliseconds. That stage, the control is transferred to execute some part of main thread. But after executing this line itself, main thread right is trying to wait for 10,000 milliseconds. So that stage, after that 5000 milliseconds is elapsed, right? Then control again goes to execute the child thread because child thread sleeping time is minimum 1.
Sir, can
Another
you
one,
explain
in
with the
this
output,
example,
sir?
what one outcome? 1 minute. First, right, what happened? Child thread demo thread by extending the thread class. That is the name of the child thread is printed. Name of the child thread here. Thread object empty is created. Then a new thread object empty is created. Thread object D is created. Sequential execution, as I said earlier, before calling the T dot start, before that, right, the sequential statements are executed. Child thread plus T. So child thread plus T, the name of the child thread is given here, string constructor. Child thread, demo thread by extending the thread class. Normally, if you print the child thread object, child thread name, what happens means in which method the child thread has been created. In main method, it has been created. And the corresponding priority that we set, we didn't set any priority. So by default, the normal priority 5 is printed. So this is the first line of output. Then have a look into here, a T dot start. T dot start started the child thread execution. So simply the control is entered into the run method. Based on the output, uh, before printing the current value of 5, right, IS 10. That stage, right, a control goes to execute the main thread. In main thread, first the value of I is printed. Main thread 10. So I can see the message main thread 10. Then main thread is waiting for 10,000 milliseconds. So that stage, immediately control is transferred to execute the child thread. So child thread I means only one value of I is printed first. For example, child thread 10. Then what happens? The child thread is waiting for 5000 milliseconds. So this stage, when the control comes back to the main thread, 10,000 milliseconds, this has to wait. But already 5000 milliseconds are elapsed. So no more executable statement in the main thread. It may go to execute the child thread activity. Child thread I is equal to 20. So child thread I is equal to 20. Then main thread, right? It may go to execute the main thread, or the order may be varying. But better to say, we need to observe the outcomes during the run. Main thread 10, child thread 10. Now there is some waiting time. Again, child thread is executing. Child thread 20. Then main thread executing. Main thread 20. Main thread is waiting for 10,000 milliseconds. So child thread, right, it finished twice execution, say 30, 40. Then main thread 30, child thread finished twice, 50, 60. Main thread 40, then child thread 70, 80. Then main thread 50, child thread 90 and 100, because main thread's waiting time is 1000 milliseconds. Child thread 90, 100, so child thread finished its execution. Then main thread is the only thread to complete its execution, but there are no executable statements other than the for. So it seems that there is a elapsing time of 10,000 milliseconds in case of main thread after printing each value of I. Since no more executable statements in the main thread, because we are hanging in this sleep statement. The main thread is hanging in the sleep statement. That's what here the sleeping time is in code. Another one in this example, new thread nt is equal to new thread. So far we have seen all the examples like this. Class name, object name is equal to new class name, constructor, semicolon. It is not necessary to have the left hand side part. It seems strange to you. The highlighted step is missing. New thread nt is equal to. This is completely valid. You can simply call the constructor using new operator, new thread. So that stage what will happen means here you must define the corresponding constructor, new thread, a default constructor, right? In that these statements can be placed. Thread t is equal to and t dot start, right? These statements can be placed as the part of the thread class constructor. I think in multithreading 6, the same has been done. Have a look into the main method. New thread, right? So in this style, right, some examples are given in the complete reference book. Do not confuse those examples. New, then what happens? The class name is given. There is a constructor. This simply calls the corresponding constructor new thread. As usual, main begins execution. First statement to be executed is this one, no doubt in that. New thread. That stage, what happens means the constructor is going to be called new thread. So the previous lines of statements, right? This one, this highlighted statement, are moved into the corresponding constructor. Thread t is equal to new thread of this which indicates that which thread is right, which object is calling this constructor. The object is currently referred by this. This refers to invoking object. So the invoking object we can write thread t is equal to new thread of this comma demo thread by extending thread class. We can print the child thread value b here. And from the constructor itself, right, you can call the start method, the t dot start. This is one possibility. Or you can call a super of something, demo thread by extending the thread class, so that this message is passed to the corresponding super class. What is a super class? Thread is a super class. To the super class constructor, we are giving this message, super of something. In this case, this statement must be the first executable statement, right? In the subclass constructor. Since a new thread is a subclass constructor, in that we can provide the message super. Then we can print the value of this and simply call start, since the invoking object is going to execute this one. Start directly calls the corresponding run method. So from the constructor itself, run method is going to be called. Right? That is the only difference. New thread, Simply flow of control is from the statement to this constructor. In constructor, right, if you want, you can create a thread class object, and using the thread class object, you call start method. Otherwise, right, if you comment these lines, simply call start method, right, inside this constructor. Start inputs the corresponding run method. This is another possibility. Having any queries in this? Extending the thread class.
Sir,
Yes.
sir, we are extending the
Yes,
thread
tell
class.
me.
We are extending the thread class now, sir.
Yes.
Sir, but in the main class we are not extending. But how can the main class then access the thread dot sleep and other members of it, sir?
Main method accesses thread. See, thread dot sleep can be given in any line. Even inside the main method, you can provide thread dot sleep. Or even in the user defined method, you can provide a thread dot sleep. Or even in the built-in method, right, like this overridden method or interface methods, you can provide the thread dot sleep. So wherever you are using thread dot sleep, right, it should be handled properly using the exception handling framework. That's what here thread dot sleep is placed as a part of try catch exception handling. Here also thread dot sleep is placed as the part of try catch exception handling. Thread dot sleep can be used anywhere, right? Even in the user defined method or even inside the main method.
But sir, in user defined class we are extending the thread by inheriting the thread now, sir.
Yeah, inheriting the thread class. Yes.
But in the main class we are not inheriting. But how can we access then, sir?
Main class, okay, good question. In main class, we are not extending the thread class. But actually, thread is in the last session, right? I have shown in the online help. You try to find that thread is 1 minute. I show it again. You try to go through this online help manual, Java. Java, yes. In this, enter into right the thread class. The thread class is defined in Java's base module, java.base, in which the package java.lang is defined. In java.lang, you can see the class thread and check its structure, how the thread class is defined actually. But in this example, right, we are simply saying we need to subclass a thread class. That means we need to extend the thread class. This is the actual structure of a thread class. Public class thread extends object because object is the superclass of all other classes in Java, including the user-defined class. The same time, the class thread implements runnable in multi-threading, sorry, in packages and interfaces, right? I have explained a class can extend, right, a superclass and at the same time implement one interface. So likewise, the built-in class thread has been designed in such a way that thread class is subclassed from the superclass object, and at the same time, it has been implementing the corresponding runnable interface, right? Implements runnable. Since the thread class is implementing the runnable interface, by default, right, the runnable interface provides a method called run method. If we click this runnable, you can see the structure of runnable, interface runnable, right? Public interface runnable. In that, you can see the corresponding method summary. Method summary is void run. So the interface runnable provides or declares one method called void run. Whenever any class implements this runnable interface, the runnable interface implemented class must redefine the corresponding run method. Now the thread class which implements the runnable interface, so you just think that the thread class is redefining the corresponding run method, public void run. So void run, which has been declared in the runnable interface, is defined like this, public void run. Now imagine that public void run, this is defined inside the class thread. But our user defined class say new thread extends the thread means already the thread class defines which one? Public void run, which is automatically taken from that runnable interface method. So in that case, the user defined class extends the thread class means we are providing overriding version. Already the thread class is providing the structure. Which one? Public void run. When same public void run is given inside this subclass, here new thread, what will happen means we are performing method overriding. That is the overridden version of this one. Run method is going to be called. Another one, you scroll down here, thread class, you can find the methods of thread class. One of the method is sleep. A sleep is a overloaded method, right? You can provide long milliseconds, and you can also provide right two parameters like this, right? And nanoseconds of thing. So in this case, sleep is defined as a static method, static void sleep. Since this is a static method defined in the class thread, and the thread is the class defined in Java's language package. Again, right? Module defined in a module java.base. But this package is automatically imported in your code. So there is no relationship from right, extending the thread class and accessing the sleep method. Because of its static nature, a sleep method can be accessible anywhere inside your code simply by calling the corresponding class name. So class name is thread, thread dot sleep. This is enough to invoke the corresponding sleep method.
Okay, sir.
So far we have seen right this one how to define the multi-threaded code by extending the thread class. So let us recall again. First you need to define the user defined class to perform a multi-threading activity that should be extended from the thread class. Second, the multi-threaded activity is defined inside the run method. Now what is actually run? Void run. Void run is the actual method of void run is the actual method of which one?
Thread class, sir.
Not a thread class. It's
Runnable.
a runnable interface. Yeah, only runnable interface defines the run method, but the structure of thread class is defined like this. Extends object implements runnable. That means the thread class, built-in thread class, implements a runnable interface. So you just think that the thread class redefines its structure, run method like this: public void run, then opening curly brace, closing curly brace. Since this is our user-defined class, right, should define the run method means when the super and the subclasses define the same method means subclass version is to be the overriding method. So method overriding is applied in the subclass, that is in the user-defined class. So inside the run method, you need to write the multi-threaded activity. In case if you are writing some other activities outside the run method means that is not the part of multi-threaded activity. For example, here instead of run method, right, you are calling some other methods means you are calling the objects, right? So T dot method 1, T dot method 2, T dot method 3. Assuming that method 1, method 2, method 3 are not defined with respect to run, are not called inside the run method means, then those methods are not actually a part of multi-threaded activity. After that, you need to define the user-defined class, that is a extended class. Here the procedure is right, a normal way to create an object of the user-defined class. User-defined class object dot we can call the start method to invoke the run method. This is one possibility. Otherwise, you need to create the user-defined class object, then create a thread class object. Thread class object is created like this. Thread t is equal to new thread of, and then specify the what you need to specify. You need to specify the user-defined class object like this. Thread t is equal to new thread of. This user-defined class object is passed as a parameter to thread class constructor. Thread class constructor, right, it takes several versions. Here you can find thread. You scroll down, you can find field summary, yeah, constructor summary. If you don't want to pass any parameter, right, that is okay. Thread, right. Then coming to this one, thread group, that is the we are not having grouping, right, multiple threads into a single group, so only one thread object is there, that is user defined object. That user defined object is passed as a parameter here. Then I can specify some message, that is string parameter value. It falls in this category, thread group comma a string name. So user defined object, then some string message. After that, using the thread class object, we call the start method. This is one possibility. Or straight away for the user defined class object, we can call a start method, right? But in the second method, when the user defined class implements a runnable interface, right? It seems that you need to follow this type. For the user defined class that implements a runnable interface, we need to create an object. That is a first step. You need to define a multi-threaded activity by implementing runnable interface. Extends thread, this one, that is changed to implements runnable. Hope you understand. Extends thread is changed to implements runnable. Extends thread means we are writing public void run, method overriding is applied. Simply extends thread is replaced by implements runnable. We are writing a public void run. That means we are implementing the runnable interface, right? Runnable interface method, public void run, so that the class rate abstract is eliminated since we completely defined the runnable interface method, all methods of runnable interface inside the implemented class, public void run. That is the second step. Run method is implemented in the the class that you implement the runnable interface. Then define the object of the implemented class. Then define the object of the thread class. And the second method, right, that we passed here, the object of the user defined class is passed to the constructor of the thread class. Same way, the user defined object for the implemented class of runnable interface is passed as a parameter to the thread class constructor. Thread object is equal to new thread of that user defined class object, comma some message, and then you can call a t dot start method. This is another possibility, right? Or the second way to define multi-threading in Java. Having any queries? The next session and explore the implementing a runnable interface, how to implement the runnable interface and to achieve the same multi-threaded activity. So in the meantime, right, I will try to go through this online help manual, right? Go through particularly this thread class variables, as we discussed earlier, right? Some instance variables are there. Max priority, min priority, norm priority, right? We click that and get the corresponding constants. A thread class constructors, a thread class method. One important method is, right, a run method, and because run is the method actually taken from which one? The runnable interface. And start method. If we call start, right, what will happen is it invokes the corresponding run method of the thread. Then likewise, right, you try to apply the stop method, sleep method. Then some other operations of that, the suspend, resume, join. These are some of the thread operations we will explore it in the next session. Having any queries? Okay, thank you very much. We will discuss in the next session.
Thank you, sir.
Thank you, sir.
Thank you, sir.